Yep.
All right. So our next unit is acids and bases, and there's quite a bit to it. We start off talking just about the characteristics and the differences between acids and bases. Talk about the pH scale. Then we're going to get into going back and reviewing acid-base neutralization reactions, which we've already been doing. They're just double replacement reactions, and where a salt and water is always produced. We're going to calculate pH and pOH, so there is a little bit of calculation to this as well. And then we'll get into naming acids. And I'm not too sure exactly the test date yet, because with the testing next week, with the STAR testing, I don't know how that's going to throw off our schedule, but I'll keep you posted. All right. Anywho. Okay. So you do need to know all these properties of acids and bases, and I'm just going to kind of go through some of them. Some of them are a little more important than others. I don't know. Important meaning that you're going to see them on your tests. Anyways, so we first talk about acids, and we describe them by their taste. What are some things that you know are sour?
Sour Patch Kids.
Oh my. There's always one that says Sour Patch Kids.
It is sour.
Oranges. Oranges have a lot.
Sorry.
Oranges have a lot of acid in them. Nick, were you going to say something? Lemon juice, yeah, very acidic.
Nice. What is the fourth one say for juice?
Oh, that milk when it goes.
Yeah, I'm gonna go through each one.
Okay.
So all those things that you mentioned, even the candy does have some sort of acidic additive or something that's added so that you get that taste. And really that sense of acid, I don't know if you've ever seen like a diagram of the tongue. There are certain parts of the tongue that register different tastes or different ions that would give you a different taste. And so acids tend to have ions that hit a certain part of your tongue that make you think it's sour. Acids are corrosive. What is corrosive?
It breaks it all things.
Yeah. And we're going to find out, just like the next line says, that they're electrolytes. When we put an acid in water, we see dissociation, and this is a word we saw in our solutions unit. Those dissociated ions can carry electrons, and if they're carrying electrons, they're getting those electrons from somewhere else. So that tends to bring out that corrosive property. And like I said, acids are electrolytes. We had talked in solutions as well about there being weak electrolytes and strong electrolytes. Does anybody remember what the difference is between the two?
Between what?
Between a strong electrolyte and a weak electrolyte. Huh? You're on the right track. The difference between the two is if you have 100% dissociation or partial dissociation. And so just like we have each of a weak and a strong electrolyte, we have strong and weak acids, and we'll get into those a little bit later. There is a very specific test that we can do on a solution to determine whether it's an acid or a base. Especially, let's say a scientist is coming into contact with a solution, they might not know what it is. Well, how you handle that solution is going to become really important. And so there is a litmus test, and the litmus test is just a piece of paper. Have you guys ever done litmus tests?
Nope.
Yes.
In 8th grade, maybe you might have, depending on where you were. It's not a taste test. It's a litmus test, and I'll show you tomorrow. It's just a piece of paper. You just stick it in the solution. If the paper turns red, then that tells you it's an acid. So James, you were asking what the fourth one down is. It's turns litmus red.
Okay, thank you.
Litmus tests are very general. They just tell us, is it an acid, is it a base? That's it. It doesn't tell us how strong, if it's a strong or a weak or anything else. And we'll do a lab where we have something that compares those different types of tests in determining acidity. Acids also tend to react with metals to form hydrogen gas. That's just kind of, we don't go too much further into that, but it is a very important characteristic of acids. And on a pH scale, which is really funny because somebody asked me for the first time, and I never thought about it. Somebody asked me, what is pH? And what does it stand for? And apparently, pH stands for prevalent hydrogen ions in this case. And I didn't even know that. It was just, I was always taught it's just pH and just accepted that, I guess. The pH scale is 1 to 14. And if we have an acid, the pH of an acid would be anywhere from like 6.99999 all the way down to 1. 7 is the neutral point, and we'll talk more about that tomorrow. A strong acid would register a pH somewhere around 1. A weak acid would register closer to 7, 7 being the neutral point. And to give you an idea of a liquid that is neutral, deionized water is a good example. Like pure water is neutral. If you were to check water from like the faucets or even maybe like some of the purified waters or like those, they have those alkaline waters now, those are going to measure either acidic or basic because they have all different kinds of things in them. But pure water is a 7.
Is it drinkable?
What drinkable?
Pure water.
Pure water? Yeah. Yeah, sure.
Leave me alone.
It's okay. It's a fair question.
It's a fair question.
All right. So then we have on the other side bases. Bases tend to have bitter taste. Can you think of anything that's bitter?
Sour milk.
Yes, dark chocolate.
It's not really bitter, but I know it's a base.
Milk.
Milk.
Is it?
Mm-hmm.
Milk? I don't even know.
Oh,
I know for sure because like when you get
grapefruits.
I asked my dad because when you eat something really really hot, you drink milk to cool down your taste buds.
You're neutralizing it.
Is that it?
Got it. That makes sense.
Grapefruits.
Grapefruits are bitter.
Yes.
I think they're more on the acidic side.
More sour. Cranberry juice. So you wanted to yell that out.
But like Brandon mentioned dark chocolate. Does anybody like to bake?
I like
Yeah.
chocolate.
Have you ever baked with like unsweetened chocolate and tasted it? Whew. Man, that is bitter. Like I make a German chocolate cake and you have to use unsweetened chocolate, and man, that is some tough.
Like it hurts your jaw, right?
It's like it makes you make this face, that's for sure. All right. Bases are also corrosive because they too form electrolytes, and we'll get more into detail. We spend some specific time naming acids because they have slightly different rules. When we name bases, we just use ionic naming rules because it's a metal and usually, or what we talk about, a hydroxide ion. And we'll talk more specifically about that later. When we do a litmus test on bases, the litmus test is blue, and they tend to have a slippery feel. What are some things that are slippery? Okay, fish. Yeah, fish are slippery. I don't know about, and that would bring up a lot of good things. I want to know what the composition of that stuff is on fish. I would almost venture to say it's probably a basic sort of slime or something. No, but like what else? What do you use every single day? What do you use every soap? Soaps are slippery. In fact, a lot of household cleaning products are bases, and
Banana peels.
we'll test some of those.
I've been to banana builders.
When we test bases on the pH scale, their pH is 7.001 all the way to 14. And I know this isn't on the slide, but I write this down because this always trips everybody up. A strong base is closer to 14. A weak base is closer to 7. So we'll talk about that again when we look at the pH scale a little bit closer.
14, and what's the weak base called?
A weak base is closer to 7. All right. There are several different ways that we define acids and bases, and there were quite a few different scientists that were involved